is drawn. My face is drawn on with this number 2 pencil. Your face is drawn. Your face is drawn from drawing words right from my...
Okay, welcome everybody. Hopefully sound and visuals are all good. We'll get started with today's lecture, which deals with non-experimental research. This is chapter 6 in your textbook. So we'll, I guess, start off by discussing what exactly is non-experimental research. Hopefully this question is something that you can answer, because we already covered the chapter on experimental research, actually directly before this chapter, right? So hopefully we already know that non-experimental research, in whatever form that it takes, and we'll see that it takes on several different types or several different designs, non-experimental research lacks the manipulation of an independent variable. So rather than manipulating an independent variable, researchers who are conducting non-experimental research simply measure variables as they naturally occur. And that could be in the laboratory or that could be in the real world. So the distinction between experimental and non-experimental research is an extremely important one. So experimental research, we have discussed, can provide strong evidence that changes in an independent variable cause changes in a dependent variable. So experimental research allows us to make causal relationships or causal statements. Non-experimental research will not allow us to do that. So non-experimental research generally can't make these types of causal statements or support these causal types of relationships, but that does not mean that non-experimental research is somehow less important. To be frank, experimental research in our field of psychology is the gold standard, but there is plenty of room, plenty of space for non-experimental methods as well. We'll see a little later on that non-experimental research often leads to experimental research. But we will rely on non-experimental research in cases where experimental research is not able to be carried out, where we're not able to manipulate an independent variable because it's impossible to do, or because it would be, let's say, unethical to do. So there's definitely a place for non-experimental research in the field of psychology. So when to use experimental research? Experimental research is appropriate when a researcher has a specific research question or hypothesis about a causal relationship between two variables, and it is possible, feasible, and ethical to manipulate that independent variable. Okay, that's the key, right? Is when it's possible, feasible, and ethical to manipulate that independent variable. That's not always, those conditions are not always going to be met. So what does that mean? That we shouldn't study a particular or we shouldn't test a particular hypothesis. We shouldn't study a particular topic because we're not able to manipulate an independent variable. Well, no. Again, ideally we would find a way to be able to test it, test this research hypothesis with an experiment, but that's not always possible to do for various reasons, right? So there are many times in which non-experimental research is preferred. Some of them include when the research question or hypothesis relates to a single variable rather than a statistical relationship between two variables. So an example might be, how accurate are people's first impressions? We could probably come up with an experiment to test that, but this is kind of more of a descriptive or explanatory type of question, not necessarily a causal question. We're not asking what causes people's first impressions to be accurate or less accurate, right? Also, when the research question pertains to a non-causal statistical relationship between variables. So an example might be, is there a correlation between verbal intelligence and mathematical intelligence? We're just simply asking, is there's a relationship between these types of intelligences, not asking what is causing the relationship, or what is the cause of each of these types of intelligences, but simply if there is a relationship between them. Also, if the research question is about a causal relationship, but the independent variable cannot be manipulated. This is often the case when we might need to rely on non-experimental type of methods, right? So an example of this might be, does damage to a person's hippocampus impair the formation of long-term memory traces? Well, you're going to be hard-pressed to find an IRB that's going to allow you to cause damage to a person's hippocampus, right? That would entail manipulating the independent variable. In this case, that's damage to the hippocampus. That's not something that we're able to do. So we're going to have to rely on a non-experimental approach to studying this question. So we're not able to actively manipulate a person's hippocampus, right? That would be highly unethical to do. Also, and finally, if the research question is broad and explanatory, or is about what it's like to have a particular experience, right? So an example here might be, what is it like to be a working mother diagnosed with depression? This is not necessarily a testable hypotheses here, right? This is kind of descriptive or explanatory. We're trying to understand the experience of, in this case, a working mother who is diagnosed with depression. This is not a research question that would be, say, appropriate for an experimental design. We're not going to be able to cause one group of working mothers to be depressed and the other group to not be depressed. So this is not something that we as researchers can manipulate. Still a very important research question, right? Even though it wouldn't be necessarily a quote-unquote experimental question, we can still explore it using various types of methods. The first method listed here, we've already talked about, correlational research. So when we talk about correlational research, the researcher measures two variables with little or no attempt to control for extraneous variables, and the researcher then assesses the relationship between these two variables. So correlational research is taking a look at whether a relationship exists between two variables, and then the strength of that relationship, and also the direction of that relationship. We also have observational research, And this is a non-experimental approach because it focuses on making observations of behavior in a natural or a laboratory setting without manipulating anything. The goal is to see what people will do in certain situations. And some really important research has come from this type of approach. And if you've taken social psych already, or even intro to psych, you should be familiar with Milgram's research on obedience, and the Stanford prison studies and Bardo's Zimbardo's study on authority, right? There wasn't really a true independent variable in these studies. They were almost simulation type of studies. They put a participant in a particular environment and basically looked to see what they would do, look to see how they responded. And these are big studies in the field of psychology in general, but particularly social psychology and legal psychology or forensic psychology. But they were not necessarily experimental in nature, right? So non-experimental studies can still be really, really important. Okay, some other types of non-experimental designs, and we'll talk about these as non-experimental designs. There are some cases where an experimental component, some type of manipulation, might be incorporated into these types of designs, but that's typically not the case. So when we talk about cross-sectional, longitudinal, and cross-sequential studies, we're basically trying to find out if there are differences in whatever research question that we are asking. If there are differences over the long run, or if there are differences between different sets of groups, different sets of age groups, essentially. So in cross-sectional designs or cross-sectional studies, this involves comparing two or more pre-existing groups of people. So there's no manipulation of an independent variable, and there's no random assignment to participants, because we might be studying, let's say millennials and Gen Xers, right? We want to determine what is their political engagement. Is there a difference in political and social engagement between millennials and Gen Xers or baby boomers, let's say? This would be a cross-sectional study because we're taking people of different age groups at this point. And we're not manipulating anything. We would just be interested in determining their political engagement or their social engagement, whatever the question might be. We're not randomly assigning anybody to these groups. They already exist in those groups by the nature of their age, right? So cross-sectional studies take a look at different age groups to see whether or not a certain variable or whatever the research question might be, whether the answer to that question changes or is different between these different groups of people. Longitudinal studies, on the other hand, study one group of people. So one group of people is followed over time as they age. So you might start at a very young age, follow a group of infants shortly after they're born, up through adulthood, and see how they progress, right, on whatever variable or whatever research question that you might have. Clearly, these types of studies take a lot of time. They take a lot of investment on the part of the researcher and also on the participants. Some of these studies can last 20, 30, 40 years, right? So there has to be funding, and there has to be a team of people, or at least some people power to make sure that these studies continue on, that the measurements are being conducted in a timely way according to whatever the research design is. So longitudinal studies tend to be pretty rare because they're so time consuming, and because they require so much so much resources. They just really take a lot of people power to make happen. So another type of study that exists, and all of these types of studies we typically find them in developmental psychology, but sometimes you'll actually find these in cognitive psychology and even social psychology as well. But for those of you who've taken developmental psych, you might be familiar with these types of research designs already. But a cross-sequential study or a cross-sequential design is essentially a combination of these two research designs, the cross-sectional and the longitudinal. In a cross-sequential study, you essentially take different cohorts or different groups of people and follow them for a certain amount of time. So it's essentially combining these cross-sectional studies and these longitudinal studies. It combines elements of both. So when we typically do cross-sectional studies, we will choose a smaller period of time, which we will follow a different age group. So one of the benefits here, say, opposed to a longitudinal study, is that it doesn't have to be as long, right? These could still be pretty long studies, pretty long observational studies, but you might not have to follow, say, someone for 20, 30, 40, 50 years. So there's some benefits to that type of hybrid model. Okay, so when we talk about non-experimental research, we have to revisit the idea of internal validity. So in experimental research, we know that internal validity is all about whether or not changes in the independent variable actually cause changes in the dependent variable. So that's what internal validity is all about. Are we really sure that changes in that dependent variable were caused by changes in that independent variable? In other words, were we able to control for all the other possible variables, all those extraneous variables that might have influenced our dependent variable? We're pretty sure it was the independent variable here. That kind of thinking changes when we're not dealing with an independent variable, right? When we're dealing with non-experimental research, we are typically dealing with low levels of internal validity. Why? Well, because there is no manipulation in non-experimental research, and there's no or very little experimental control in non-experimental research as well. In the next chapter, or chapter coming up here, we'll talk about quasi-experimental research. And quasi-experimental research kind of falls in the middle between, say, legit 100% certified experimental research and these non-experimental research methods. Quasi-experimental research tries to contain some of the properties of an experimental design, but it tends to fall short of being a true experiment. So in terms of thinking about internal validity, are we really sure that this variable is causing changes in that other variable? We're talking about internal validity here. Correlational and other types of non-experimental designs would be pretty low on the scale of internal validity. Experimental designs, particularly those that have a lot of experimental control, would be higher in terms of internal validity. And we'll see in the next chapter that quasi-experimental designs tend to fall somewhere in between here. Okay, so correlational research, again, something that we have spoken about quite a bit already, but when we've spoken about correlational research, we've mostly spoken about correlation as a statistical procedure, even though the data that we analyze came from correlational research. So we also talked about the correlational research method, but consider this a review, so to speak. So correlational research is a type of non-experimental research in which the researcher measures two variables, and they can be binary or continuous. Actually, that's something new, something that we haven't discussed yet in this class. Up until this point, I've been teaching correlational, or let's say correlation as a statistical method, as the Pearson product moment correlation, meaning that we're examining two continuous variables here. But you could actually do correlational research with binary variables as well. That's something we might as well take a look at if we when we revisit linear regression. Maybe I'll throw in a binary variable there so we can see how correlation might work with a, let's say, binary variable, a yes or no type of variable. Basically, binary variable means there's only two options there. So it doesn't necessarily have to be a continuous variable. That's typically how correlation is taught. So the researcher will measure two variables and assess the statistical relationship, the correlation, between these variables with little or no effort to control extraneous variables. So there's no experimental control, there's no independent variable, no manipulation of a variable going on. We're simply looking at the strength and nature of a relationship between two variables. So when is this used? Well, it's used because the researcher does not believe that the statistical relationship is a causal one, or is not interested in causal relationships. So sometimes we're not interested in whether X is causing Y. Sometimes we just want to know, is X and Y related somehow, right? The researcher, it's also used when the researcher cannot manipulate the independent variable, again, because it's impossible, impractical, or unethical to do. So if we're trying to do research on whether or not smoking causes lung cancer, it would be pretty unethical for us to do an experiment on this, using humans at least. That means we would have to randomly assign young people to a smoking group and a non-smoking group, and basically follow them through their lives to see which group will develop more lung cancer than the other. That would be unethical to do. A lot of research involving climate change. There are plenty of the whole issue of climate change. I don't want to get into the minutia of it. There's tons of research out there involving many types of research designs and many different types of data that exist out there, including experimental data, or experimental studies rather. But if we just want to focus on the grand question, the big question of whether or not pumping more CO2 into the atmosphere is causing a increase in global temperatures, this would be pretty impossible or impractical for a researcher to do, right? For a single researcher or even a single institution to do. There would also be clear ethical concerns associated with that. So we might also use correlational research designs to establish the reliability and validity of measurements, which we have discussed already. When we get reliability, particularly reliability, right? Reliability is measured using correlation coefficients, essentially. Whether that's inter-rater reliability, whether that's split form or split test reliability, test retest reliability, whether that's internal reliability or internal consistency. These all use correlation coefficients as a measure of reliability. Also, when we measure the validity of measurements, we've already discussed that measuring validity is a little trickier. You have to get a little bit more creative. But even then, we're still relying heavily on correlation coefficients. So, is my measure of variable x correlated with this already established measure of variable x, right? We would use a correlation coefficient to determine that. When we talk about divergent validity or convergent validity, those are correlation coefficients. So correlation is definitely very helpful in establishing reliability and validity of our measurements. Often, when we talk about correlational research, it's often higher in external validity, even though it's lower in internal validity compared to experimental research. Why? Well, remember, external validity deals with whether these results can be applied to the real world, something outside of the laboratory. Correlational research is usually done outside of the laboratory. It's usually done using quote-unquote real-world data that already exists out there. The problem is we don't have a true independent variable, and we really don't have much of any experimental control or control over potential extraneous variables. So correlational research tends to be high in external validity in terms of its generalizability, but lower pretty low in terms of internal validity, because there are any number of variables that could be affecting this relationship. Also, correlational research can help to provide converging evidence for a theory. So again, without necessarily running an experiment, and this is kind of how people or scientists were able to prove that smoking actually caused lung cancer. A number of experiments were done on animals, particularly mice, having mice smoke cigarettes and see the rates of cancer there. But the tobacco industry would come back and say, well, these are animal studies. How do you know they apply to humans, right? There was enough correlational research, and not just correlational research, but also regression, right? So we spoke about regression and we learned about regression, but the beauty with regression is that it is an extension of correlation. It's an extension of the correlational statistical methods, except you get to throw in every conceivable variable, right? You get to throw in everything. So when the tobacco industry was like, well, how do you know it's not the person's diet that's causing them lung cancer? Okay, well, let's throw in that variable into the regression model. Does smoking still come up as a significant predictor? Hey, look, what do you know? It does, right? Oh, well, how do you know it's not the place they live, if they live next to a factory or something? Okay, let's throw that variable in there as well. So, basically, when we, it's the mantra that we teach you, that correlation does not, what's the mantra? It says correlation does not imply causation. I always get about that. It's probably a good mantra for intro students, which again, this is just part 2 of an introduction to methods and statistics class. But with enough correlational research, particularly with enough regression models that get consistently replicated, correlation can't prove causation, but it sure as hell can imply it, right? So that's basically how the tobacco industry had to admit that, yeah, smoking causes cancer, right? The correlational research was so overwhelming, and not just the correlational research, but the regression research. Control for every variable that the tobacco industry was coming back with. Hey, how do you know it's not this? How do you know it's not that? All right, let's throw that into the regression model. Hey, look, even when we take that into account, smoking is still a significant predictor, or still the most significant predictor, right? It's kind of hard to escape that, especially paired with the non-human experimental research that was being done. Okay, so also when it comes to correlational research, when it might be used is that when a researcher wants to study binary or rank order variables. That's not something that we have touched upon in this class, rank order correlation, but there's Spearman's correlation, which allows you to evaluate ordinal variables, the correlation between ordinal variables or ordinal variables and other types of variables. So Correlational research is actually really important, particularly when it comes to developing your measures and testing the reliability and their validity. Correlational research is often the jumping off point. You notice, okay, there's a strong correlation going on here, going on there, and if you're doing regression and you're able to throw in some other variables that you use as a control, say even when we control for this, there's still a relationship here. It's implying a causation, right? You're going to have to run an actual experiment to determine if there really is a causal relationship. But correlational research is very useful in terms of leading to experimental or testable hypotheses, experimental designs, experimental research. So just as a review for the third time now, when we talk about the correlation between quantitative variables, we're dealing with Pearson's correlation coefficient, also known as R. And this is a statistic that ranges anywhere from -1 to +1. And again, it describes the strength and the nature or direction of a relationship between two variables. So if I get my head out of the way here, you can see a -1 correlation is a perfect correlation. There's between, remember, this is our x-axis and our y-axis here. As we move 1 unit up on the x-axis, we're moving 1 unit down on the y-axis. This is a perfect negative correlation. By the time we get to, say, -0.5, which is considered a moderate-ish correlation, a small to moderate correlation here. Take a look at the scatter plot. We kind of see a pattern going on. It's certainly not a perfect pattern. Those lines aren't lining up perfectly, but we could see some kind of pattern going on. It looks like as we increase on variable x, we are decreasing on variable y. A correlation of 0, as we can see, has no discernible pattern. This doesn't look like there's any relationship between these two variables, x and y, at all. Once we get to a +0.5, basically just the mirror image of the -0.5, these correlations, +0.5 and -0.5, they're the same strength. These are just as strong in terms of their relationship between x and y. It's the direction that's changed, right? In the negative correlation, as we go up on x, we're going down on y. As in the positive correlation, as we go up on x, we're also going up on y. So we see a correlation or pattern that is positive, right? And then when we get to a positive, perfect 1 correlation, as we move up 1 unit on x, whatever that unit might be, whatever that measurement might be, whatever value of x that might be, we're increasing the same amount or the same proportion on y. So as I've said before, seeing perfect correlations, whether they're negative like this one or positive like this one, or even seeing a correlation of 0, -1, +1, 0, these are all pretty rare to find in actual data, in real data. Why? Well, because of statistical noise. So even if you do have a perfect correlation between two variables, which would be very rare in general, the fact of the matter is, no matter how good your measurement is, it's probably not 100%. There's still probably some measurement error in there, which is going to probably knock down this perfect correlation. Maybe you'll get close to perfect. Maybe you'll get 0.98 or something like that. But statistical noise, statistical error is just a fact of life that we deal with as psychological scientists, right? The same goes with a negative correlation, or zero correlation, right? Just statistical noise is likely to push this a little bit either positive or a little bit negative, just because of error in our measurements, especially because of, think about the types of things that we study. We study constructs. We study things that can't be easily measured. So the measurement errors, again, just kind of a fact of life here. Okay, so when can correlations be misleading? So Pearson's R is a good measure only for linear relationships. So these are relationships in which the points are best approximated by a straight line. So when we did a review of correlation, we were talking about linear correlation. When we learned about regression, we learned about linear regression. If you remember, the regression line, the line of best fit, is literally the formula for a straight line, right? So correlation is not good for non-linear relationships. So what do we mean by that? Well, non-linear relationships are where the points better approximate a curved line. This is an example here. We can see that there is a clear relationship between our x variable, hours of sleep per night, and our y variable, depression. So it seems like you sleep 4 hours a night, right? So less sleep seems to be related to higher depression scores. Start getting into that sweet zone that people are always telling us about, that 7 to 9 hour zone, right? Looks like depression scores go down. But sleeping longer hours, going into the 10, 12, 13 hours of sleep, is related to higher levels of depression. Now again, this doesn't mean that the number of hours that you sleep per night is causing changes in depression. It's just related to it. So people who, let's just say, have depression, one of the symptoms of depression is a disturbance in sleep. But it could go either way. It's either you're not sleeping enough or you're sleeping too much, right? And that's kind of reflected here in our data. People with high depression scores are either getting 4 or 5 hours of sleep, or they're getting maybe too much sleep. The point being, though, for us is not the issue of causality here. If we were to use regular linear regression or linear correlation, we might not see a relationship at all. This might come up as a correlation or an R of 0 or close to 0, right? Why? Well, because remember, with correlation and regression, we have the line of best fit. We only have one straight line that has to account for all this data. again, a straight line. We can't bend it this way. So a straight line might cut right through all of this data, or maybe right here, and it would pretty much be flat, right? So we would totally miss out on any type of relationship that's going on between these two variables with just traditional correlation or traditional regression. So remember, correlation, regression, as we've learned it, we can only use these with linear types of relationships. Another situation that we can run into when using Pearson's R is when one or both of the variables have a limited range. So what does this mean? Well, let's take a look at this data down here, right? So on the X variable we have age, and on the Y variable we have enjoyment of hip hop. I don't know when I'm looking for the date of this scale or this graph right here, but we can see that the data might be skewed quite a bit, because it seems like, okay, as you get older, just by looking at this data, it looks like appreciation for or enjoyment of hip hop tends to decrease when it comes to say getting older, right? Especially once we start getting into the 40s. Somehow we pop up to hip hop in our mid-50s to mid-60s, and then it tails up again. The problem is right here. Right. So if we take a look at this age group, we don't have anybody younger than this age group. So we have a bunch of scores right here that are extremely high. Let's say I'm just guesstimating here, say age 15 to 25-ish, let's say, right? So we have a big let's say interest or enjoyment of hip hop in that age range, but we have nothing before this, right? So we actually have a restriction of range. We don't have the full picture here. So I'm just taking a look here. It says the hypothetical data showing how a strong overall correlation can appear to be weak when one variable has a restricted range. So the overall correlation here is negative 0.77, but the correlation for the 18 to 24-year-olds is 0, right? So if we were to take a look at just this age group of 18 to 24-year-olds, I was close, I said 15 to 25-year-olds, yeah, it doesn't look like there's any correlation going on here, right? It looks kind of flat. There's no pattern. Overall, if we look at the whole say scatter plot, it shows right here overall correlation of a negative 0.77. So as we get older, less enjoyment for hip hop. But in this particular age group, it looks like there's no relationship whatsoever. This is pretty misleading, right? Especially if people wanted to cherry pick this data. You might even be able to cherry pick this. I can't select it. Oops. Let me go back here. You might even be able to cherry pick this data, or even cherry pick this data right here and say, hey, there's not much of a correlation between age, like middle age, and enjoyment of hip hop. So the problem again is that we're only taking a look at a part or a section of the X variable, right? So if we only looked at, what is this, 18 to 24-year-olds, it would show a correlation of 0. No change in enjoyment of hip hop. But if you started to expand your range and started to study people outside of that age group, you're going to start seeing a noticeable negative correlation there. I'm not going to reveal my age here, but I was around in the 90s, and I have a great appreciation for 90s hip hop. So let's just say I'm somewhere in this area, over here. That's all I'll say. But Missy Elliott is the shit. That's what. That's what I'll say. And Snoop Dogg, of course. How can you not? Public Enemy, right? So many. Okay. Getting away from my taste in music here. One of the issues that we again drill into your head is that correlation does not imply causation. I said maybe in maybe 3 or 4 more statistics classes from now, we might be able to put an asterisk next to that statement and talk about the nuances that might exist. But for your purposes, correlation does not imply causation, right? But just remember, regression is a very powerful tool. I use regression for everything. Ever can't fall asleep, you need something to put you to sleep, go look up some of my publications and read the results sections. It's all regression in there. I love it. I love regression models. Path analysis, that's my jam. Okay, so well, that might not be fair now that I'm thinking about it. Those path analyses are done in the context of an experimental design, but okay, like I said, for the purposes of our class, correlation doesn't imply causation. Why? Well, because we have the directionality problem. We don't know, is X causing Y or is Y causing X? Who knows, right? We also have the third variable problem. Maybe there's a third or fourth or fifth or sixth or God knows how many other variables out there that are actually causing both of these variables to appear like they are related. And finally, we have spurious correlations, just by chance, just by serendipity. It just doesn't mean anything, right? So an example of a spurious correlation, the number of people who drowned by falling in a pool correlates with the number of films that Nicolas Cage has appeared in. So if we take a look at these, the black line is the number of Nicolas Cage films by year, if we're looking at the x-axis. And the red line is the number of people who are drowning in swimming pools on the y-axis. Take a look here. So look at the number of drownings on the y-axis, number of years. This looks like a pretty disturbing pattern. It looks like Nicolas Cage is responsible for a whole lot of deaths by drowning. He's a horrible actor. He makes horrible films, so it's possible that somebody watched his film and decided to end it all, right, by drowning themselves in their pool. Not likely, right? This is an example of just a coincidence, right? So we have to be careful when dealing with correlational research. Even though it could be pretty useful, there are some severe limitations to it. Okay, so speaking of correlation, and again, some of this we have mentioned before in terms of complex correlation and the correlation matrix. Most complex correlational research involves measuring several variables that are either binary or continuous, and then assessing the statistical relationship that exists among them. When we run correlation in SPSS, we're presented with a correlation matrix. This shows the correlation between every possible pair of variables that exist in the study. And as I've said before in previous lectures, only half of the matrix is filled with information. Well, in SPSS, the whole thing is going to be filled in. But when we report it, we typically only report half of the matrix. Why? Well, because it's a mirror image of itself. And where there are dashes here between these variables, saying we entered all these variables into SPSS and we got a correlation matrix, what exists on this side would also exist on that side. There's a lot of redundancy that exists in a correlation matrix in the SPSS output. And where there are dashes here in the SPSS output, we would see ones, because need for cognition, variable X would be perfectly correlated with itself, variable X, right? So it's kind of useless information. We tend to substitute those ones with some dashes, and we just get rid of the redundant information just to make it easier to visualize. And those of you who have gotten in the third assignment now, you realize, like, yeah, it could be pretty confusing when you have multiple variables in there that you're trying to run a correlation with, and you're presented with this massive correlation matrix, and you're like, why is it running it both ways? That's what SPSS will do. It will test say intelligence and need for cognition, and then it will test need for cognition and intelligence. So this value here would be the same value there. When we present the data, because our goal is to present research results in the most understandable way, simplest way possible, we remove the redundancy. In the meantime, just might have to navigate through a couple of these correlation matrices in SPSS to kind of understand the redundancy and kind of know where exactly to look for the information that you need. It's a matter of just practice. Okay, another form of complex correlation is something known as factor analysis. And believe it or not, when there was a point where even when I started teaching here, that 222 was a 4-credit class. And when I taught 222 as a 4-credit class, I actually taught factor analysis. Why? Because I think it's really cool, and because I'm like a scale geek. Again, go check out my publications. I created like 3 or 4 scales. I don't even know. Excuse me. So factor analysis, we're not going to learn about it in this class in much detail, but it's in your textbook, and it's something that I very much enjoy, so I definitely think it's worth talking about. So when researchers study relationships among a large number of conceptually similar variables, we'll often use a statistical technique called factor analysis. You might notice I left out that word complex statistical technique because it's not that complex. I mean, okay, SPSS is doing all the work, so I'm sure it's very complex, the math behind it. But understanding it is not very complex. It shouldn't be something that you're afraid of or that should turn you off in any way. So in essence, factor analysis organizes the variables into a smaller number of clusters, such that they are strongly correlated within each cluster, but weakly correlated with other clusters. Let me put that into just normal speak, normal English there. If you have a whole bunch of variables, or let's just say we're creating a scale, a depression scale, let's say. There are lots of different symptoms associated with depression. Some deal with mood, some deal with behaviors, some deal with cognitions, some deal with relationships, right? Let's say we come up with 20 or 30 different questions. We're going to create a depression scale, a new depression scale. We come up with 20 or 30 questions that we want to ask people. We test it out. We have people fill out these 20, 30 questions. What we can do is use factor analysis to see which of these questions are tapping into maybe the mood aspect of depression, right? And which of these questions are tapping into the behavioral aspects of depression or behavioral symptoms of depression, so on and so forth. We might also find that some of the questions that we asked on our scale aren't really measuring anything. They're not lining up with any of these symptoms. They're probably shitty questions. We should probably toss them out. They're not good for our scale. So factor analysis basically finds patterns in data. How are people responding to certain questions? Well, they seem to be responding to these sets of questions in a certain way, and they seem to be responding to these sets of questions in a certain way, and those sets of questions in a certain way. But that's really all that factor analysis is going to tell you. It's not going to tell you what those factors are. It's just going to say, yeah, on your 20 scale item, question 1, 10, 15, and 18, yeah, people, that seems to be a thing. Whatever those questions are, people are responding to those in the same way. So you might want to look in and figure out what the hell those questions are measuring. Essentially what factor analysis does, which is kind of cool, right? But you're still kind of left hanging with determining what are those questions measuring, right? So 2 points about factor analysis that are worth mentioning is that these factors that are produced are not categories. Factor analysis doesn't tell us that somebody is depressed or they're not depressed, or that their behaviors are mimicking depression or not mimicking depression. It's just telling us these items are clumping together. People are responding to these things in a certain way, and these items in a certain way. So it's still up to us to determine, to interpret what those factors actually are. So when we get the results of a factor analysis, which might look something like this, it's up to us to label these factors, to actually determine what they are, what these factors are actually measuring, and what the cutoff point is, right? So in this example that I just took from your textbook here, it says factor loadings of the 14 musical genres on 4 Varimax rotated principal components. Don't worry about that fancy language. Okay, so it's basically different genres here, right? So we see blues, jazz, classical, folk, rock, alternative, so on and so forth, and music preference dimensions. So you see here there are labels, but you would not get these labels in a when you run your factor analysis. It's just going to say factor 1, factor 2, factor 3, factor 4. That's it. This up here, musical preference dimension, you ain't getting anything up there. Literally factor 1, factor 2, factor 3, factor 4. But you could say, okay, so factor 1, what's loading, quote unquote, loading on factor 1? Well, blues, 0.85. We can interpret these factor loadings like correlations, right? So you'd say, wow, blues seems to be pretty correlated, so to speak, with factor 1, whatever that is, and doesn't seem to be like correlated with any of these other factors. So I'm going to say blues kind of belongs to factor 1. Same with jazz, right? Jazz 0.83 and doesn't seem to be correlated with any of these other factors. So on and so forth, right? So it looks like blues, jazz, classical, and folk, these all look to be moderately to strongly correlated with factor 1, whatever that is. We don't have a name for it yet, right? And then we go to rock and we're like, ew, so rock, what is rock music associated with factor 1? You're like, whoa, correlation of 0.17. That's like nothing there. But wait, 0.85. Yeah, rock music seems to be associated with factor 2, whatever that might be. And you go down the list and you can see here, on this table, the factor loadings have been bolded for you, right? So, but you would do this, you would go and eyeball. Sometimes it'll be close. You might have country music that's like 0.62 and a 0.72, and you're like, oh, this is kind of seems to be kind of loading on both of these factors. What do we do then, right? It's beyond the scope of this class. But once you start, let's say, using factor analysis to see, okay, blues, jazz, classical, and folk, those all seem to be on some factor. Now it's up to you as the researcher to decide, well, what do those 4 categories have in common, right? And let's say you are a researcher or psychologist who's interested in creativity or the music and psychology, whatever the case may be. Well, in this case, they came up with reflective and complex, that this is a dimension of music that's reflective and complex. Blues, jazz, classical, and folk, right? When it comes to this next factor that we see, rock music, alternative music, heavy metal music, those seem to be loading on a different factor. So what do all those three things have in common? These researchers determined that, well, they all tend to be pretty intense and rebellious, maybe nonconformist, right? Whatever. So the point is that you're going to have to determine what those factors are. Factor analysis is just a statistical tool to let you know which variables are kind of going together, right? And if they're clumping together, then these four variables might be related in some way, or they might be capturing some conceptual variable or some quote-unquote dimension of music in this case. So factor analysis is kind of cool if you ask me, but it's because I use it all the time, so I'm biased, right? Another complex form of correlation, one can argue, right? Regression is an extension of correlation, and we've already discussed regression in great detail. So again, consider this slide just a review, so to speak. But once a relationship between two variables has been established, researchers can use this information, use this relationship, to make predictions about the value of one variable given the value of another variable. So once I know the relationship between x and y, well, then I should be able to plug in a x variable and get out a predicted y variable. And that's exactly what regression allows us to do. So it's a statistical technique that allows researchers to predict one variable given another variable. Regression could also be used to describe more complex relationships between more than two variables. This is what we call multiple regression. So multiple regression is kind of cool. And again, if you ever really have nothing else to do, go take a look at some of the publications that I have. I use regression all the time. Why? Well, because it allows me to control for all these different variables, right? So I could throw in variables. Just as an example, my dissertation dealt with people's perceptions of domestic violence or intimate partner violence in same-sex couples versus opposite-sex couples. And no surprise, I found that people saw domestic violence or intimate partner violence as being less serious when it happened in same-sex couples. And I'm like, okay, so what might account for that? Well, clearly homophobia, right? Could be an explanation for that. But also gender roles, right? Maybe it's not necessarily homophobia per se, but maybe it's just, well, a guy should be able to defend himself better against another guy than, let's say, a woman would be able to defend themselves against a guy, just based on gender, right? So I tested, people for homophobia. I included a homophobia scale. I included a gender role belief scale in there, and I threw it all into the model. And guess what? Homophobia and gender role beliefs did not fully account for the difference that I found. So I'm like, damn, okay, there's likely something else going on here. And some of you might be asking, well, did you test a sample of gay people to see what gays and lesbians and bisexual people, how they reacted? And the answer is yes, of course I did. I got a PhD. They're not gonna let me not do that. Right? So yes, I had to cover all my bases. And yeah, I saw the same pattern. Even LGB people saw or rated same-sex violence, intimate partner violence as less serious. And of course, for that group, I included an internalized homophobia scale, and I also included the gender role belief scale. And yeah, even in that group, those scales did not fully account for this difference. So I have a follow-up study to do. I have an idea of what it could be. So any of you who are interested in that line of research and interested in getting some research experience, hit me up, because you need to light a match under my ass to get me to do the follow-up study. I have an idea of what it might be. And if you've taken cognitive psychology and are familiar with prototypes, and you might be feeling my vibe that I'm putting out there. Okay, so as we know with regression, typically the variable that is used to make the prediction is called the predictor variable, or if we're doing multiple regression, we'll have multiple predictors. The variable that we are trying to predict is often called the outcome variable or the criterion variable. And in simple linear regression, as we said before, we just use the formula for a straight line. And in this case, it's y prime. We have a little apostrophe next to that y value because it's a predicted y. Sometimes we'll see, remember, we might have a little hat on the y, on the y symbol there, and we call that y hat. So it's y hat or y prime, and those symbols exist because it's to denote that this is a predicted y-score. It's not an actual y-score. There's going to be error in this score. This is just a prediction based on the relationship that we know between x and y, right? So in simple linear regression, our predicted y-score is just a, which is the y-intercept, plus b times x, where b equals the slope. So we're able to find a, the y-intercept, and find b through hand calculations that are part of calculating correlation, or as I showed you in SPSS, it's super easy to find those the values there. So when it comes to multiple regression, it's just an extension of simple regression, right? There'll still be a predicted y variable, but instead of just using one predictor x, maybe, well, that should be 3 there, not 2, 2, 2, 2. So imagine a predicted y variable is the y-intercept plus the slope of x1. So plug in your value for x1, and the slope for variable 2 or predictor 2, and plug in your value for predictor 2, and that should be 3 and 3, and so on and so forth. So multiple regression allows us to use multiple predictors to come up with an even more accurate or more complete predicted y variable. Okay, qualitative research. So we spoke a little bit about this earlier in the semester when we were talking about different levels of measurement, and when we were talking about different measurement types, right? When we were talking about observational research. So qualitative research, this course that we are taking now, 222 and 221, is primarily a quantitative research course. We're dealing with numbers here, and we primarily focus on quantitative research because that's what most studies in psychology are. They're quantitative in nature. Once in a while, you'll see some qualitative research pop up, particularly in maybe the beginnings of a new area in social psychology, perhaps, or developmental psychology, or maybe even clinical psychology. But it's rare. We pretty much deal with quantitative data. We deal with numbers in psychology. So qualitative research is typically seen in fields like anthropology and sociology, even though sociology is becoming more and more quantitative in nature. But again, it's still used to study psychological topics as well, just not as often, right? So qualitative researchers generally begin with a less focused research question. They'll then collect large amounts of relatively quote-unquote unfiltered data, so kind of just raw data, big net, trying to collect as much information as possible from a relatively small number of individuals. So say a group, sometimes it's a single individual if we're talking about a case study. And then they'll describe their data using non-statistical techniques such as grounded theory, thematic analysis, critical discourse analysis, or interpretive phenomenological analyses. They are usually less concerned with drawing general conclusions about human behavior than with understanding in detail the experience of their research participants. Now, I don't want to knock qualitative research too much because I'm a cognitive psychologist, but pretty much study social issues. And as an undergraduate, I had the pleasure of taking a course with the author of the book called The Cocaine Kids. And it was a totally biased book, a totally biased qualitative study. He would readily admit that. He did admit that very much so in his book. But this was, at that point, it's an undergrad. When I take that class, maybe 1999 or 2000. And this was about a group of crackheads, essentially, in New York City. that this professor, he's a sociologist, or he might have been a psychologist who studied drug use and abuse, but nobody had studied this population before. The 1990s was very much law and order, crackdown on crime, mandatory sentencing. Nobody gave a shit about this group of people. But he's, over the course of a year or maybe even two, studied them, got into their circle, and it's riveting. It's not a novel. It's his work. It's the result of his qualitative research, but it almost kind of reads like a novel. And yeah, he got attached to the subjects that he was studying, and he was not able to maintain complete objectivity, right? And yeah, that happens when you're living amongst a group of people that society has thrown away, right? But to go through the book, it was really powerful for me, and I understood the benefit of qualitative research. Just hearing these stories and this narrative, was it top-notch science? No, not at all, right? Tons of subjectivity, tons of problems that exist in there, but it was the first step to understanding this population. It humanized this population. It led to more research, to empirical research, to experimental research, and it led to changes in the drug laws in New York State. We used to have the Rockefeller drug laws, which were barbaric, just a minimum sentencing for just possession of crack cocaine, which of course these laws targeted black communities, right? And as a teen and as a college student, we would protest all over New York City, and even in Albany. I take the train up here to protest the Rockefeller drug laws. We say drop the rock, right? Eventually it did, but I'm bringing all this up because qualitative research often plants seeds for further research and even policy changes. It's important. It's important stuff. Okay, so the purpose of qualitative research. So qualitative research can help researchers to generate new and interesting research questions and hypotheses. So clearly, qualitative research it's often just the beginning of a line of research, right? Qualitative research can also provide rich and detailed descriptions of human behaviors in the real world context in which they occur. Exactly what I was just describing in terms of the book, the Cocaine Kids. I think that was really important for people to read that book and see that, yeah, these were people who needed help not to be thrown away, right? Qualitative research can convey a sense of what it is actually like to be a member of a particular group or in a particular situation. So what qualitative researchers often refer to as the quote-unquote lived experience of research participants. So this is a bit of a double-edged sword. I haven't personally gotten in trouble, quote-unquote, in trouble with this. But, we hear this all the time. As psychologists, we conduct research, and not everyone is going to be 100% happy with the results of our research. And we might have studied a topic and studied hundreds of participants to reach our conclusions, and someone says, well, that doesn't apply to me, right? And we'll say, well, yeah, okay, of course, right? But we're not saying that this applies to everybody. We're saying these are patterns. These are the results of our study, right? But one person's individual lived experience does not negate an empirical study of hundreds or thousands of people, right? So it's important to of course take people's lived experiences into account, but in the context of research, these are often outliers. These are often exceptions, right? We're not saying when we conduct a study and find results that everybody is going to follow these types of behavioral patterns or think in this way. There's always going to be exceptions, but lived experience can easily become anecdotal evidence, let's say. At the same time, as qualitative or quantitative researchers, right, we're collecting data and running stats all the time. Sometimes it's actually good to have these types of narratives. Sometimes it's good to have these type of anecdotes, these type of lived experience stories to kind of give a broader context to our data, to our numbers, to help us really kind of understand them a little better, right? So in terms of purposes here, just going through, qualitative research will use in-depth information about relatively few people, where quantitative research, we use less depth information with lots of people. Qualitative research, the conclusions are based on interpretations drawn by the investigator. So the researcher will basically go through and say, okay, I think this is what's going on. With quantitative research, conclusions are based on statistical analyses. With qualitative research, it tends to be more global, more exploratory. With quantitative research, we tend to be more specific and focused. In particular, we're focused on null hypothesis testing. We have a hypothesis and we want to see whether it's supported or not, right? Okay, so how does data collection and qualitative research actually work? How does it happen? one of the most common approaches, especially in psychological research that is qualitative in nature, is to conduct interviews. So you just need to talk to people. And interviews can take on several forms. The first is an unstructured interview, and this consists of a small number of general questions or prompts that allow participants to talk about whatever interests them, whatever comes to mind. So you're basically trying to get narratives out of participants. So you might just ask a little question and it can turn into half an hour answer. So you say, have fun coding that response or making sense of that response. That's tough, right? Because some people like yours truly can talk forever. So that can be hard to do. There are also structured interviews where there's a pretty strict script that the interviewer will stick with and won't deviate from. So not a lot of room for the participant or interviewee to kind of go off on tangents and whatnot. And then we have the semi-structured interview, which is actually the most commonly used type of approach. So the semi-structured interview, the researcher has a few consistent questions. So they're asking specific questions to get specific answers to, but then they can follow up by asking more detailed questions or even more broad questions about the topics that come up. So there's a set of questions that you have to ask, but you could always follow up with, tell me more about that, right? So you're getting the data that you want to get, but you're also in the semi-structured interview allowing the interviewee to provide more of a narrative or to provide more information beyond what you asked. Another approach in qualitative research involves small groups of people who participate together in interviews that are focused on a particular topic or a particular issue, and this is known as a focus group. So the use of focus groups has become a standard technique in business and industry among those who want to understand consumer trends and consumer preferences. We also see the use of focus groups used for political strategy or by political campaigns for political messaging and whatnot. The content of all focus group interviews is usually recorded, and then it's transcribed to facilitate further analyses. Basically, the researchers will try to pick out or try to uncover patterns that the people who were participating in the focus groups had brought up and discussed. When it comes to analyzing data in qualitative research, there are a number of ways to go about analyzing qualitative data. Statistics is not one of them, clearly, right? But the primary way is what's known as grounded theory. So with grounded theory, researchers start with the data and develop a theory or an interpretation that is, quote unquote, grounded in those data. So you will start with the data first and go through the data and basically try to identify patterns, try to identify themes, try to identify whatever might whatever might be useful in there in trying to understand the grand scheme, to try to understand all the data, right? So you're using the data to develop a theory, essentially, right? Now, that could happen in quantitative research as well. Yeah, right? I mean, theories are our best explanation of what's in front of us. So in quantitative research, we have a bunch of statistics, a bunch of data, a bunch of analyses in front of us. And we'll come up with theory. I mean, we'll test hypotheses that come from that theory, but it's not so different, right? This idea of grounded theory. Let's say the issue here is that you're kind of letting the data drive the theory rather than letting the theory drive your interpretation of the data. But I don't know if that's necessarily a bad thing, right? I tend to be more of an exploratory researcher. I mean, it's probably just a result of my ADD, is that I go look at my research. I'm all over the place, right? So it's kind of, I don't know if that's necessarily a bad thing. So when it comes to grounded theory, first, researchers identify ideas that are repeated throughout the data. Then they organize these ideas into a smaller number of broader themes. So that actually sounds a little bit like factor analysis, right? We have statistical programs that do factor analysis for us, that organize these different variables into broader clusters. So there's no statistical data here, there's no numbers here, but it seems like the researchers are kind of doing the same thing, right? Finally, the researchers will write a theoretical narrative, which is an interpretation of the data in terms of the themes that they have identified. And that can be a research report, or it can be a book. It can be a paper presented at a conference. Again, it's driven by theory. I would say, as a quantitative researcher, I would say awesome, great start. Next step, let's test some of those assumptions that you made using experiments, right? So that's where I would go. But that's because I'm a psychologist and you're a psychologist. So qualitative research definitely has its place. Just to finish off this chapter, speaking about themes and identifying themes, like how do we actually identify particular themes, and what's this notion of repeating ideas. Believe it or not, I've had to do content coding, which is exactly this. I have a whole bunch of data dealing with stereotypes of LGBT people, and I just asked people, list 10 stereotypes about gay guys, and 10 stereotypes about lesbians, and 10 stereotypes about bisexual people, and I asked a few hundred people to do that. And then I had to read, well, not me, but some research assistants had to go through them and identify themes, right? So let's say this theme of ambivalence here, a repeating idea, right, that we would say kind of not qualify, we would like categorize as quote unquote ambivalence might be, let's say we're reading through a narrative. Somebody wrote a story, or we're listening to a tape of someone speaking, and they said, I wasn't prepared for this baby. I didn't want to have any more children, right? So we can classify that theme as ambivalence, even though I'm looking at that here and I'm like, not sure where the ambivalence comes in. Ambivalence, remember, in psychology means you have strong positive feelings and strong negative feelings. I don't know, do you see any positive stuff in there? Just saying, maybe it's me. Another theme, caregiving overload. Somebody saying, please stop crying. I need a break. I can't do this anymore. Right? You would label those types of statements, those recurring or repeating ideas, all kind of make up this theme that they're burning out, right? They're kind of in over their head. Okay, so that's the last slide for this lecture. The next two chapters I'll try to combine. They deal with quasi-experimental research and survey research. So I'll try to do both of those as one lectures, even though they're separate chapters. Okay, that's it for now. I need to drink a bunch of water because my mouth, it feels like I got a big cotton ball in it. So I will see you all soon. Take care. Bye-bye.